Accurately, the topic is isolation, identification, and analysis of menthol. Menthol is colorless, optically active compound of molecular formula C10H20O. Menthol has characteristic refreshing odor. It has unique cooling characteristics. Due to refreshing odor and cooling characteristic, menthol is used as flavor and fragrance. Menthol vapor is significant antitussive and is commonly used in cough preparation. For informative points of pharma, make sure to subscribe the channel. Here we will begin with sources of menthol. Menthol is obtained from natural sources as well as by synthesis. In natural sources, menthol is found in essential oil of mint plant. Now coming to the menthol rich essential oil. Cornmint oil and peppermint oil are two mint oil which are rich in menthol content. Cornmint oil has about 70% menthol. Cornmint oil is obtained from Mentha canadensis, also known as Japanese mint. Coming to peppermint oil, about 75% of peppermint oil is a mixture of menthol and menthol. Peppermint oil is obtained from Mentha piperata, also known as peppermintha. So, cornmint oil is the best source for isolation of natural menthol. The production of menthol from cornmint oil occurs through a number of steps. The entire process can be divided in two parts, that is distillation and crystallization. Coming to distillation. Usually cornmint plant is distilled by farmers in their field using water cum steam distillation unit. Distillation is also performed on large and commercial scale. Here we will know only infill distillation unit, and infill distillation unit contains four parts, that is furnace, distillation tank, condenser and receiver. Furnace is the part that provides heat for distillation. In infill distillation unit, agro waste, firewood and straw are used as fuel. Now coming to distillation still. The distillation still is a tank made up of stainless steel and is placed above the furnace. Internally, the tank is provided with a perforated grid at the base. The third part of distillation unit is condenser. Condenser is tubular pipe which connect distillation tank to receiver. Condenser is provided with inlet and outlet water for cooling. The fourth part of distillation unit is receiver. The receiver is placed below the condenser. Now coming to distillation process. The tank is packed with partially dried mint harvest. Water is added to the tank to a lower level. Furnace is ignited to provide the heat for distillation. On heating, oil and water vapor evaporate. The vaporized mint oil and water vapor undergo condensation in the condenser. The condensate passes to the receiver. Oil, which is lighter, floats on the water. The floating oil is drawn off. Anhydrous sodium sulfate is added to collected oil, left for 4 to 5 hours and filtered thereafter. Distillation actually yields the volatile oil from which menthol is isolated by crystallization. The next step is crystallization. From cornmint oil, menthol is isolated through stepwise crystallization such as fast crystallization and slow crystallization. Fast crystallization is the initial crystallization due to low temperature, whereas the slow crystallization is the recrystallization by gradual temperature reduction. The entire process of crystallization of menthol from cornmint oil can be studied under following heading, such as fast crystallization for the formation of menthol powder, separation of menthol powder, preparation of enriched menthol solution, and slow crystallization. Coming to fast crystallization, crude cornmint oil is filtered to remove water and foreign matter. The filtered oil is vacuum distilled to remove top note. Top notes means a small light molecule that evaporate quickly. The filtered oil now has menthol content 68 to 78%. The oil is placed into slightly tapered galvanized steel container. The containers are placed in deep freezer for fast crystallization. Temperature of deep freezer is maintained at -40 or lower. The crystal formed in deep freezer is called menthol powder. The next step is separation of menthol powder. Containers are removed from freezer after crystallization. Container removed from freezer has two components, that is menthol powder and residual oil. Residual is the dementholized oil left after crystallization, which is known as dementholized mint oil or DMO. Coming to container, containers are inverted on a drip tray to allow DMO to drip out. Block of menthol powder is broken up. The broken menthol powder is centrifuged to remove the rest of residual oil. Now, preparation of enriched menthol solution in DMO. Menthol powder is melted. Melted menthol powder is mixed with a small portion of DMO to produce enriched menthol solution in DMO. Enriched menthol solution has menthol content about 88 to 94%. The solution is filtered. The filtered solution is poured into second galvanized steel container. The containers are placed upright in a second freezer for slow crystallization. Now coming to slow crystallization. Slow crystallization is operated under a strict control cooling regimen in the second freezer. Cold contact is applied at the bottom of container. The cooling regimen is carefully controlled from room temperature to -10 over a period of 15 to 35 days. To assist crystallization, the enriched solution is seeded with pure menthol. Slow crystallization yields the final product, that is menthol. Now, separation of menthol. When crystals have formed throughout the container, it is removed from the slow crystallizer freezer. Containers are inverted on drip tray to allow DMO to drip out. Large crystals are carefully broken up and centrifuged to remove any residual occultated DMO. The menthol crystals are now graded into large, medium, and small crystal. The further process include drying and packaging. This is about isolation of menthol. Now, identification of menthol. Menthol is 2-isopropyl 2-methyl cyclohexanol. Naturally occurring menthol is laboratory, where the synthetic menthol may be laboratory or racemic mixture. Coming to identification, menthol is colorless, hexagonal or needle-like crystal or infused mass or crystalline powder. Menthol has characteristic and refreshing odor. The molecular formula of menthol is C10H20O. It has molecular mass 156. The melting range of menthol is 41 to 44 degree. The specific rotation of 10% solution in ethanol is -49 to -51 for natural menthol. For racemic mixture, it is -2 to +2. Now coming to TLC analysis of menthol. The TLC analysis of menthol include stationary phase, mobile phase, standard solution and test solution. Here the stationary phase is pre-coated silica gel TLC plate. The mobile phase is toluene and ethyl formate in the ratio of 7:3. The standard solution is prepared by dissolving 10 mg of methanol reference standard in 10 ml of ethanol. The test solution is prepared by dissolving 10 mg of test methanol in 10 ml of methanol. Procedure: apply 10 microgram of test solution and standard solution separately on TLC plate. Develop the plates in mobile phase till the solvent rises to a distance of 8 cm. Visualization: observe the plate under visual light. Spray with Komorowski reagent. Heat at 105 degrees centigrade for 5 minutes and note the RF value and color of the resolvent. Now evaluation of TLC. A band at RF 0.65 corresponding to menthol is visible in both standard and test solution. This is all about menthol. Hope you enjoyed the session. Soon we will meet with another topic. Thank you.